In composites industry, QC testing impacts both quality of products and success of businesses. By investing in QC testing processes, composites manufacturers can enhance their competitiveness and reputation while delivering reliable and high-quality products to their customers. Various techniques of inspections include visual inspections aided by dye penetration, coin or hammer testing, portable ultrasonic detection, mechanical testing, radiography, RT, and structural strength testing, SST. As you go along with this lecture, all these techniques have been described for the benefit of workers, supervisors, and factory owners. Many non-destructive testing methods abbreviated as NDT exist that can potentially be used for assessing quality of finished composites products. The testing method must be selected after considering several factors, like the cost involved, the time required, the access to the composites products, and the ability of the method to serve the required purpose. All these methods require trained personnel for setting up, calibrating, operating the equipment as well as interpretation of test results. Hence, qualified manpower must be employed and deputed for QC laboratories. QC testing has a significant positive impact on both product quality and the success of businesses in the composites industry. Quality testing is an essential requirement to maintain high degree of quality and reliability. Control of incoming raw materials is the key to success of any manufacturing setup. Different quality control techniques applied in fiberglass composites industry are shown on the screen. All these techniques will be described in detail in the preceding slides. Visual inspection is probably the most widely used test. It is simple, easy to apply, quickly carried out, and usually low in cost. The basic principle used in visual inspection is to illuminate the test specimen with light and examine the specimen with the eye. In many instances, aids are used to assist in the examination. Equipment for visual and optical tests include magnifying glass and mirrors. Portable microscopes also provide very high power magnification. Portable units with computer displays allow recording to evaluate suspected indications found on the structure. Magnifying glass, magnifying mirror, and portable microscope are shown on the screen. Some endoscopes and borescopes provide magnification option and zoom controls. Woven stainless steel sheathing protects the image relay bundle of flexible optic borescopes during repeated flexing and manowavering. The working lengths are normally 60 to 365 cm. Image from video image scope may be magnified for precise viewing. The field of vision is up to 90 degree and probe tip has four-way articulations. An image of endoscope is shown in next slide. Image of a typical endoscope equipment is flashed on the screen. Tapping is the simplest non-destructive testing method for composites. By tapping the composite with a coin, or a metallic object, or hard rubber hammers to evaluate changes in the sound. Stethoscope can be used as aid. Analyzing the sound in comparison with the response of defect-free part allows determination of product health. This procedure aids in detecting delaminations and voids. Images of coins and stethoscope are shown on the screen. One of the oldest of modern non-destructive testing methods is dye penetration, which points towards presence of any gaps between two adjoining surfaces and presence of porosity, treating the area with an appropriate liquid of high mobility and penetrating power so that it enters the surface cavities to reveal the flaw pattern under light. White light is sufficient when visible dye penetrants are used. However, when fluorescent penetrants are used, ultraviolet light lamps are required. Dye penetration method provides economic and rapid visual evidence of cracks, porosity, lapse, seams of other surface discontinuities. Spraying dye penetrants is another variation. In this process, after a certain dwell time, the composite is wiped clean and a developer is applied. The developer, usually a dry white powder, draws out the penetrant from the cracks and pores. Visual inspection is then performed. With portable equipment, aerosol penetrant testing are performed on installed parts of a complex composite structure. This is particularly useful for aircrafts and boats. Stationary test equipment, used in fixed installations, consists of a series of modular workstations that include deep tanks for penetrant, emulsifier, and developer. Besides these, drain or dwell areas, wash area with appropriate lighting, drying oven, and an inspection booth form part of the setup. Small parts and test pieces are loaded into wire baskets and then processed through each of the stations, while large components are inspected in automatic system. Ultrasonic tests are primarily used for the detection of crushed core and sandwich structures. It also detects debonds in adhesive bonded honeycomb and delimitations in composite structures. Principle of sonographic testing originates from time taken to bounce back of high-frequency sound waves pulses. This allows the detection of voids and delimitation inside the composite. Shadowing effects are due to attenuation and scattering effects. These are controlled by appropriate selection of probe and adjustment of pulse parameters. Various defects encountered in sandwich and other composite structures are shown on the screen. Few variations resulting in high-level detection equipment working on the principles of ultrasound and resonance testing are briefly introduced on the screen. Practical working of ultrasound equipment and detection capabilities are shown in the picture. Mechanical testing helps verify that the product meets the stipulated industry standards and regulations, ensuring its quality and reliability. It helps optimize the material selection process by identifying the most suitable material for a particular application based on its mechanical properties. Mechanical testing of composite materials can present complex problems, but is essential in order to ensure the reliable, safe and cost-effective performance of any engineering structure. It focuses on high modulus, high-strength fiber and resin composites, and covers highly anisotropic materials such as carbon, aramid and glass. As one of the most common forms of composite testing, tensile testing is one of the most effective ways to measure a material's yield strength. Among other things, yield strength is the point at which a material will begin to deform when placed under stress. Other tests include measuring flexural and shear strength. All these tests provide valuable insights into the material performance in applications where bending and shear stresses are significant. In radiographic characterization, high-speed electrons interact with the nucleus of the target material and convert it to X-ray energy. The areas so exposed become darker when the film is immersed in a developing solution. After development, the film is rinsed to stop development. Damages located at depth of tens of millimeters can be detected. Major drawbacks of radiography are very high cost, strict health regulations and the fact that it only detects damage that is parallel to the beams. Radiographic characterization is essential in aerospace and marine industries. Radiography is beneficial in tracing delimitation, cracks and foreign inclusions, density and thickness variations. Configuration of X-ray equipment is enlisted in this slide. Few images of radiographs characterizing composite structures and fibers are flashed on the screen. In many products, metallic flanges and other structures are attached to fiber or carbon composite storage tanks, which requires proper X-ray analysis of metal parts of composites products also. One most popular application involving these is the gas storage tanks. Structural strength testing, also known as SST, is applied both in destructive and non-destructive modes. The former is required for qualification of the structure, while non-destructive mode allows verification of the quality of the product to be supplied for use. It is particularly useful for aircraft qualifications. Different experiments involving SST are shown on the screen. Important web links related to technology education and mentoring center are flashed on the screen. More lectures describing various aspects of ensuring quality of products will be uploaded on our YouTube channel.